Ракетная атака.
Есть
Старт
новая дрон,
подводный.
ракетная атака.
Глубина старта 75 метров.
Рубежи обороны, командир рубежей обороны, командир отсека.
Выработать нормальные условия старта.
5, 4, 3, 2, 1, 0.
Начало залпа. Пуск.
Есть пуск.
Imagine a missile that can fly forever. No fuel limits, no safe zones. A weapon that could circle the globe, vanish below radar, and strike from any direction at any time. That's not science fiction anymore. It's Russia's newest nuclear cruise missile, the 9M730 Burevestnik, NATO codename SSC-X-9 Skyfall. Tonight on Global Briefing, we'll dig through the facts, numbers, and secrets behind one of the most ambitious and controversial weapons ever designed. And we'll ask, is this the dawn of a new nuclear age, or the world's most dangerous experiment? Burevestnik means storm petrel, a small seabird known for flying straight through tempests. Russia picked that name on purpose. The missile is meant to glide under chaos, unstoppable and unseen. Technically speaking, the 9M730 Burevestnik is a nuclear-powered, nuclear-armed, long-range cruise missile. It's launched from the ground, flies at extremely low altitude, sometimes just 50 to 100 meters above ground, and, in theory, has unlimited range. Unlimited, that's the key word, because unlike normal cruise missiles that run on fuel, this one is said to use a miniaturized nuclear reactor as its engine. If true, it could stay in the air for days, even weeks, waiting for orders to strike. In March 2018, President Vladimir Putin unveiled 6 invincible new weapons. Among them, the Burevestnik. Back then, many Western analysts thought it was propaganda, a PowerPoint weapon, a way to boost morale at home. But behind closed doors, testing was already underway in the Arctic, at remote launch sites near Novaya Zemlya and Pankovo. Satellite photos later confirmed strange structures, heat signatures, and temporary radiation spikes. By 2025, those whispers turned into a public demonstration. On October 21st, 2025, Russia claimed the Burevestnik flew 14,000 kilometers, about 8,700 miles, over 15 hours of continuous flight. Do the math. That's roughly 930 kilometers per hour, or 580 miles per hour. A speed similar to a commercial airliner, but with one crucial difference. This missile doesn't land. According to Russian media, it launched from the Arctic coast, crossed parts of the Barents Sea, looped north of Norway, circled over open ocean, and returned safely. If those numbers are accurate, it's the longest cruise missile flight in history. And if the nuclear propulsion truly worked, it's also the first flight ever powered by a compact nuclear reactor. Of course, no independent sources verified these claims, but US and European radar systems did detect a long-duration unidentified flight pattern that day. See, coincidence? Maybe not. Let's unpack how a nuclear-powered cruise missile might even work. A normal missile burns liquid or solid fuel. Once the tank's empty, it's done. Burevestnik, on the other hand, reportedly uses a tiny nuclear reactor that heats incoming air, then ejects it through a nozzle, creating continuous thrust. In principle, this gives practically unlimited endurance. In practice, it opens a Pandora's box of problems: radiation shielding, overheating, waste heat signatures, and crash contamination. The last part is important. In 2019, a failed Burevestnik test of the Nyanoxa range caused an explosion that killed 5 engineers and released radioactive isotopes into the air. Locals were told not to swim, fish, or touch the shoreline for days. That accident earned the missile its dark nickname, Flying Chernobyl. Believe it or not, this idea isn't new. Back in the 1960s, the United States had a top-secret project called Pluto, a nuclear-powered cruise missile that could stay airborne for months. Project Pluto worked, sort of. The prototypes ran successfully in Nevada, but the US canceled it, realizing the environmental risk was catastrophic. Every test left a radioactive trail behind. 60 years later, Russia revived the dream and the danger. Only this time, technology has advanced far enough to make mini reactors plausible. So why pursue such a weapon? Because modern missile defense systems like the American Aegis, THAAD, or Patriot PAC-3 can intercept conventional ICBMs or cruise missiles. But they can't intercept what they can't predict. A nuclear-powered missile could fly under radar for thousands of kilometers, take detours around known defenses, and strike from unexpected directions, even from the South Pole. Russia's message is simple. You can't stop us. A question for you. If a country builds a weapon that can fly forever, untouchable and unstoppable, does it make the world safer or more unstable? Let me know what you think in the comments. Let's address the elephant in the sky, nuclear pollution. A missile powered by a reactor releases trace radiation even in normal operation. In a crash, it could contaminate an entire region. After the 2019 explosion, radiation levels in nearby Severodvinsk spiked 16 times above normal. Russian officials later downplayed the incident, but independent monitors confirmed the data. Critics warn that every test adds radioactive risk to the Arctic, one of the planet's most fragile ecosystems. And here's the irony. The Burevestnik might never need to be fired to cause harm. Simply testing it already carries a cost to the environment. From a military standpoint, the Burevestnik could reshape deterrence theory. For decades, global stability relied on mutually assured destruction, predictable ICBMs, satellites, early warning systems. But a low-flying, nuclear-powered missile throws unpredictability into the equation. US analysts suggest it could render existing defense networks obsolete. In response, NATO countries may invest in new detection systems focused on ultra-low altitude and long-endurance threats, an expensive technological arms race. Russia's economy struggles under sanctions, yet it continues to pour billions into strategic weapons. Why? Because each successful test serves as geopolitical messaging. When the Kremlin showcases a 14,000 kilometers flight, it's not just engineering, it's psychological warfare. It tells the world, even if you isolate us, we can still out-innovate you and threaten your defenses anywhere on Earth. The Burevestnik fits perfectly into that narrative. In Washington and Brussels, reactions have been cautious but concerned. The Pentagon confirmed it monitored a long-range test consistent with Russian missile activity, but avoided technical commentary. The UK's Ministry of Defense called the project reckless and destabilizing. Meanwhile, NATO's strategic planners are updating doctrines to include nuclear-powered airborne delivery systems, a category that didn't even exist 5 years ago. This shows just how much one experimental missile can reshape global policy. The Burevestnik's nuclear engine reportedly uses a fast neutron reactor smaller than a refrigerator. Some Russian engineers call it the ever-flying bird. The missile's testing grounds have radiation monitoring drones permanently stationed nearby. In 2023, the Norwegian Radiation and Nuclear Safety Authority detected short bursts of xenon gas near the Barents Sea, believed to be from early engine runs. The U.S. Department of Energy compared its theoretical design to Project Pluto Mk2, noting similarities in airflow and shielding design. All of this points to an extraordinary effort, but one built on dangerous complexity. Weapons like Burevestnik aren't only about defense, they are political theater. Each new test boosts domestic pride, distracts from economic woes, and reinforces Russia's image as a scientific powerhouse. It's propaganda fuel, literally and figuratively. A single Burevestnik unit could cost as much as $100 million, though Russian budgets remain secret. To put that in perspective, that's nearly the same as 10 Su-35 fighter jets. So the real question becomes, is this sustainable innovation or costly illusion? Despite all the headlines, here's what's missing. Verified footage of the 2025 test, independent measurement of flight path or radiation, confirmed deployment timeline. Until those emerge, analysts treat every statement cautiously. Russia insists the system is nearing operational readiness. Western intelligence quietly suggests it's still in advanced prototype stage. Truth, as usual, is somewhere in the classified middle. If the Burevestnik truly works, it changes global deterrence forever. If it doesn't, it still forces the world to react and spend billions on new defenses. Either way, Russia wins the psychological game. Fear costs money, and that's the currency of modern geopolitics. Show map of flight path, Arctic loop, 14,000 kilometers. Overlay specs chart, speed, altitude, range. Insert 2019 Oxer explosion photo. Displays satellite imagery of Vologda 20 launch complex. End with a cinematic shot of the missile emerging from Arctic mist. So here we are. One missile, two truths. Either Russia has built a weapon that rewrites the laws of warfare, or it's chasing a ghost powered by nuclear dreams. What's certain is that the Burevestnik has already succeeded in its mission of fear. It reminds the world that the race for invincible weapons never really ended. It just went nuclear again. Thanks for watching Global Briefing. If you want clear, fact-based reporting on global conflicts, technology, and geopolitics, subscribe now. It helps independent journalism thrive. And tell us below, do you think Russia's Burevestnik is real power or real propaganda? Stay informed, stay curious, and as always, this is Global Briefing.